Hello and welcome back to the lab. Today on the bench we have some more SG505 and AA501 distortion analysis and trouble in the lab. In a previous video we took a look at my SG501 option 2 unit that was having some frequency stability problems. Well, in part of the validation of the SG505 I dug into the AA501A and as well as this AA501, and it turns out the AA501A is performing fairly well. This AA501 is not. This is out of specification. Also, since we can do the validation now, this is my other non-option 2 SG505. This is a, I think this is an option 1 because I have the intermodulation but I don't have the balanced output. So I want to work on this SG505, but I'll show you what's going wrong with the 501. So if we hit level, we will adjust this to 250 millivolts. 252 millivolts, that's good enough. So at 254 millivolts, because this is the specification is over 250. If I set this to THD plus noise in RMS mode, we'll let this count down. And it's actually struggling to find it, but this was not happy when I was doing some distortion analysis. Because I don't have the A-weighted filter on. If I A-weight the filter, we'll see a reduction, but it's still not even going to settle. So with the 80 kilohertz low pass on, it's having trouble. If I kick up the signal to 500 millivolts, just under 500 millivolts, will perform a lot better. Spec on this unit is 0.025% THD at 250 millivolts. So the notch filter or the distortion amp has drifted out of spec in the AA501, but also we may have some stability problems with this SG505. Now on my AA501A, the other unit that I have in the lab, this SG505 tests very similar to my other SG505 in similar conditions. So as it sits right now, my thinking is the problem is going to be in there, not in there. But since we can do the validation, we're going to put some capacitors in here as well just to quiet down the power supply, maybe bump a couple of values up a little bit just to make it a little more quiet and give it some better filtering, because for those who followed the channel for quite some time, my lab is an incredibly noisy place. This is getting hard for my lab. We don't have that chirping because you'd see it here, but when we're getting into distortion measurements that are this low, really we should be talking Faraday cage, doing these inside of a Faraday environment just to keep the noise out. I do not have that at facility number 1. That is going to probably be a consideration for facility number 2. For those that are following the channel, the lab is rapidly outgrowing the space, so we are talking about a second facility where the lab and the shop is going to move to, because I'm running out of place for storage of components and repairs and things like that, and I also need to spin up the dirty side of the lab. I'm very rapidly running up against, I need to do some machining and things like that, so more is on the way for sure. It's going to get pretty deep in the weeds, which is where the fun is. But for now, we're going to take on these 2 units, and we'll see where this video takes us. But down the rabbit hole we go. On the AA501, a quick pop off of the cover plates, and it looks like we've already done some recapping here. These are caps that I typically use in the lab, and I am sure these did not ship with the unit. So I think I have already done a bit of corrective maintenance on this particular 501, so this may just need the distortion, the notch in the distortion meter retweaked. But let's pop this open. To get this back cover plate off, I'll need to, I would need to take off. Oh, that's a little loose. Wonder why. Oh, those need a smaller bit. It's part of my problem. Much more positive. Okay, that's locked in now. Huh, a couple of screws were loose. I want to take this top cover off and look for some other capacitors, see if there's any that I may need to swap out. Where's my other bit again? Tektronix, for whatever reason, love to use posi-drive screws. These are not Phillips. Somebody's used Phillips on here. He has kind of chowdered the screw out. I don't know if the camera's going to pick it up, but right here there's a little line at the edge of the screw. No, the camera's not going to show that at all. But it uses a posi-drive bit. Those look very similar to Phillips, but they are not Phillips. And Tech did like their posi-drive. Yeah, that's another cap I've already done. Those two. Yeah, it looks like we've already recapped this pretty well. So, all right. Are we gonna be an adjustment fun? I can't do these adjustments with the cover on because I believe these two potentiometers are some of the ones I'm gonna need to dial for the distortion meter. So, oh, here's the for those that are curious, I have talked about the relays that are in the AA501 with the relay adapter boards and things like that since I have this one open. There is our block of 4 right there, and there's our extra 1 over there. So it's that set of 4, that one, and then there's that Caddick ceramic resistor. That's actually a Tech part number though. 307. Yeah, that's a Tech part, at least in this one. So that's how far you have to dig in to get those relays replaced if you're going to do one of these, and they are in the same place on the 501A, very similar. So this unit has been recapped already. I worked on this one a while ago, so I could not remember if we'd actually put capacitors in this one or not, but it does appear we did. So I'm going to focus on the SG505, and then we'll also dial in the distortion on this again to make it work better. Okay, so here's the back side of a SG505, and then on the flip side, we are over here. I have already done capacitors in here too, but there's a couple more on this mezzanine board, and I think there's a couple underneath that may need to be done. So let me get this board out, and we'll just swap a couple of caps. Okay, we have the mezzanine board with the caps replaced. I did find a slight, very slight bit of electrolytic leaking out of this one, and this one was very slightly domed. So in time for replacements, but timely replacements. So that needed to be done. But we'll get this put back in there. This is actually a really quick job. There's not much to... There's a lot less to do in a non-option 2 505. And everything's all back together. One trick to getting these connectors out, which is kind of a pain, but if you're going to remove some boards, sometimes these rods need to come out. If you put a flat blade screwdriver in and twist, it'll open up the connector and they just pop off. And then they put them back on the switch. You just push and they latch, and then that's done. So that's a full recap of one of these. The tantalums looked good. Everything looked okay. So I'm going to turn on the scope And we'll throw this back in the power frame and see, and just check its output. We'll also check this one against my known working AA501 just to make sure we didn't screw up the distortion spec. And then we'll work on tuning up that other 501. All right, while the scope warms up, we'll get the 505 connected. All right, we're on the right channel. Set this to a kilohertz. Output on, and we'll ground the BNC. No smoke, please. Also helps if I give it an appropriate amount of signal. Wow, way too much signal. There we go. Okay. I had the SG505 turned all the way down. Oh, no more noise on the cal control. Nice. On the variable. So I did give it a standard service when I had everything open, since I'm going to validate the THD. Figured I'd give it a service, and having it open, might as well while I was there, because really the step on these is messing around with the the frequency knobs working. Messing around with the unit can disturb the total harmonic distortion spec, but we're going to check that, so do everything while we're there. Okay, I have it set up to the AA501A, which we know was in good shape and everything was working. We're set to 0 dBm into a 600 ohm signal. Actually, I can even get a shorter BNC cable. Okay, short BNC cable. We are on THD auto with a low pass filter on. We are not A weighted. Let's see what it does. I'm not going to complain about that. It's not even warmed up. So that looks like it may have helped quite a bit. Let's see what if we take it off of grounded does. Not much. And if we differential this, and ground that, 13%. So yeah, it is. That actually cleaned that up a lot because it was struggling to get down. It was running about 25-ish, 0025, and struggling a bit. So definitely have problems with that other 501. So we're going to tackle that here in a second. But I'm going to let this sit here and cook for a little while, let it burn, just to make sure we don't have any problems. But it's not looking good for my other distortion analyzer, that's for sure. Okay, I've got the SG505 in. These have been warming up for a while. The AA501 is hooked up. These two lines coming off the AA501 are going to be really important here in a second. We have the input monitor, which is just a normalized signal from the input. It's amplified or attenuated depending on which one, so it's a great way to look at what's coming in on the front of the scope without disturbing the device under test. The function output, which is the next one over, that is what's coming out post-notch and essentially the, quote, noise that the AA501 is measuring. Now, the problem with the function output is it gives you an idea of the noise components but not their levels. Because this is an amplified signal, you have the noise of the 501 embedded in the signal. Now, for an amplifier or something like that, not a problem at all. You can even do spectrum analysis on there. You can do spectrum analysis on that port as well to kind of see what the noise components are, but the amplitudes will not be correct because it's the AA501 has added its own distortion into the signal, and it's changed the signal from the input. It's not just notched out, but what the scope is showing me, which I'm going to move over to here in a second, confirms my suspicions. And here we go. So on the top side of the scope, we have the input monitor here. Let me get a pointer. So we have input monitor here, and then we have post-notch filter here. Well, that looks quite a bit like I have signal leaking through the notch because that's the same frequency. Now, it is phase shifted. So that's why the peaks don't line up a little bit, because they're just going through the amplifiers. Any amplifier is going to add a little bit of phase shift to a signal. So this is perfectly fine. But because I have fundamental showing through, my nulling circuit and my notch filter is out of adjustment on this 501. So we will have to go through. I did double check this 501 against my other 501, and they're agreeing with the measurements. So the level sets are fine. They're agreeing with all that. It's the distortion that's messed up. So we can do an abridged calibration and just do the distortion side of the unit, and we don't need to worry about the meter side. So I am going to press into service. I'm going to see if we can do a little bit better than the calibration document, and I'm going to press into service an AM502. A lot of people have been asking what one of those units is good for. This is one of the perfect use cases for an AM502. I'm going to put that in between the function output of the AA501 and the scope, because the AM502 is going to give me some more gain. Because if we take a look, let's see, read out our second trace, which I'll move to the bottom so we can keep this straight. So we have trace 1, trace 2. Trace 1 is at 1 volt per division, which is fine. Trace 2, on the other hand, is at 5 millivolts per division. So we're at the bottom end of this plug-in already, and that's how low a signal I have. I actually have the scope triggering off of channel 1 just so I can get a stable signal. So putting the AM502 in the mix is going to increase the gain of that signal, let me look at it, and let me do the adjustments and even get it tighter than normal than just using the scope plug-in. So we're going to try that, see if it works. Okay, we got a lot going on here, so I will talk about this. So I have the output, the function output, going up here, pardon the camera movement. We're going up to the AM502. The AM502, I have it set to DC coupling. We have the high pass set to, let's bump this to 3 kilohertz. Since we're going to do this adjustment at 500 hertz, 3 kilohertz is fine. I have both inputs DC coupled, but the negative side is grounded. The positive side is coming from the function input. And we're coming out of the AM502, and we're going into the Rigol. Turned out I needed to do a little, I'm actually going to use both scopes for this. So here's what our noise looks like. So we have the Rigol set to 20 millivolts a division. It was much easier to see the noise on the Rigol because the trace was moving around so fast on the phosphor, it was actually losing a lot of this data, so I switched over to a digital. But keep in mind that this is our noise, and I've got full display, but the AM502 is giving me a gain of 20,000. So we have a 20K gain coming out of the front function output of the AA501 going into the Rigol. So we're really digging this noise out of the noise so we can see it and do the adjustments. Now my job for adjusting the 501 is to null out this noise, get the notch to cut this out and make it look as good as we can. So let me do that real quick, and then I'll bring everybody back. Well, some things have progressed. Obviously, the unit is apart on the bench. So, after playing with the adjustments, these two adjustment potentiometers up here, and having the unit recapped, here's some of the new capacitors we put in. We're having a problem with the noise floor. It's too high. Where I should be having a noise floor of about 0.0012% distortion, I'm getting 0.038, so I'm about triple what I should be in terms of the distortion spec. And the nulling out and things like that isn't doing much. Also on the scope, I was seeing some harmonics leak through. I was testing it at 1 kilohertz sine wave, and I was seeing some 3 kilohertz harmonics leaking through. So we have some interesting issues with this unit. As you were talking about before, these are the relays that the relay boards go into. The other thing with the AM502, I had that set up incorrectly at first because I did not have the output actually, or the input actually turned on. I had to back the gain way down to 100 and pull out even a little bit more signal. So good use for the AM502 if the technician sets it up correctly. In this case, I didn't. I've ordered some replacement parts. We're not going to parts cannon this thing because I don't know exactly what's going on, what's wrong quite yet. However, I want to focus on these op amps, all of these little 8-pin dip packages. These are all op amps that are doing various things in the circuit, and they are all on NTI sockets. So what I'm actually going to do is I'm going to resocket all of these op amps. It's going to take a little bit, but I have a desolder gun, so it's going to be quick. Where I don't want to go is we have a couple relays here that may need to be changed. One could be getting noisy with a noisy contact. The other thing that I really don't want to have to mess with is these packages right here. These are photo resistors. So there's an LED in there which is controlling a resistive element, and they're also in the nulling and feedback path, or nulling and signal conditioning before it hits the distortion. So I am hoping these Veritex are not the problem. If it's not the sockets, my next question is gonna be, is it an IC that may or may not be bad? And then we're gonna really start looking hard at these Veritech parts, because these they're also an active part, so they could be problematic, especially with the noise I was seeing, because I was seeing intermittent noise. The notch was working, then it wasn't working, then it was working, then it wasn't working, then it was working, then it wasn't working. So, but it wasn't working not long enough for the device to settle and give me a good reading. So the notch is for sure intermittent, and I'm getting stuff through that I shouldn't be. So now we're going to find... Now we get the fun troubleshooting of trying to find an intermittent issue. The good news is with the op amps, they're all TL072s. So if I do need to swap the op amps to new op amps, that is a relatively available part number. This NEC 5532 is not. So that one might be... there's 2 of those on this board. They might be hard to source. Actually, there's 3 of them. But the other ICs should be okay. A lot of that's switching logic, a couple of 14 series logic. But we'll see where it goes. So we're going to start with sockets. I got to wait on the mailman. Hello? Is that solder splash or is that roasted tantalum? Might be solder splash. That's not good. That means somebody may have been poking around these varactors before. Interesting. Looks like we have a crack in this relay too. It's funny how the more you look at stuff, the more you notice. So, keep at it, but we have a noise problem in here. The good news is my SG505 is working. We know for a fact the noise is in this unit because doesn't matter what power frame I put this in, doesn't matter which SG505 I use, I get the same readings, so at least it's consistent, which is good. So we'll get some sockets put in and see how we go. Well, the delivery man has come and gone, and we have 2 rails of Amphenol 8-pin sockets. I was expecting more rails than this, but I guess when you order 120, I wasn't expecting just 2. But I got a lot of soldering to do, so the FR410 will make quick work of that, and the Heiko iron will zip this all out. I'm going to do one at a time, be real careful with the static on the ICs, get everything all squared away, and then we'll check some noise and see what happens when we come back. But for now, I have all of these op amps to resocket. Hopefully we don't have to get into relays or photoresistors. Well, that was a job and a half. Very happy I had the desolder tool for that one. I have all the op amps resocketed, and someone has had a go with this board before me, so I'm not the first one in here, that is for sure. There's also a couple of interesting points to be aware of when attempting this job. One of them is right here, where this capacitor hooks into an op amp pin. The other one is right here, where we have a piece of Teflon wire. Let me zoom way in. Pardon all the movement. So we have a piece of Teflon wire that dives in from the top side of the board and hooks to that pin of the op amp. So we had some interesting connections on here. We also had some questionable joints too. This is from, yeah, those aren't caps. So this is from a previous repair attempt, I'm assuming, on this one. But I'm ready to put this all back together, and I'm going to do a little bit of flux cleanup, and then we'll see if we made a difference or not, made it worse, made it better, and figure it out from there. Okay, I have the AA501 all put back together. Getting the push buttons through the front face of the unit is not the most fun thing on the planet, but we got it done. I'm going to get this, put in the frame, hook it up to the SG505, and then we will see if we made an improvement, made it worse, blew it up. Let's see what happens. Okay, I have the 505 in, 0 dBm signal, and it's hooked up for the distortion nulling. Let's see what happens. No smoke. Well, that's a good sign to start. We're still a little high, but it's stable. Let me hook this up to a scope. Let's see what's going on. Okay, so I've hooked up a scope to the function output. I'm going to move you guys over to the 7603, and we'll take a look. Okay, we're on the 7603. We'll give it some brightness. All right. Well, we have a decent signal. Let me get the shade over it so it's easier to see. There we go. We have a decent signal, but we have a sinusoidal signal, which we shouldn't have because this is post-nulling, so the nulling isn't right, but it's not strobing like it was before. So let me see if we can't null this out. Well, that answer is going to be no. So we increased the stability, but we made the distortion slightly worse because it was getting down to 0038. Now it's 0040. Let's see, we'll go to level. Yeah, so we have a notch problem. But the good news is, at least it's a consistent notch problem. So we'll be able to troubleshoot this and figure it out. So now the question is, where do we go from here? Okay, we are back in the circuit, and we're troubleshooting these VacTech devices are photoresistors. So there's a diode in here that is lighting up a resistor, which is changing its resistance. It's how a lot of the servo control works in an AA501. It's actually one of the key parts so the op amps can control the circuit. So if we go to the cell side of things and we hook up test the resistor, that's testing at about 42 megohms, 46 megohms. Cell side of this one's over here. We're testing 1.7K. Let's see, 1.8K. And which one's cell side? I think it's this side. Yeah, 1.7K. So I have 3 of them testing in the 1.7K range and 2 of them testing in the 40 megohm range. So I think we may have some parts that are bad. So let me get these sucked out, and we'll actually test these with the SMU and a DMM. Okay, I've picked up a data sheet, and I am asking the SMU to give me 1 milliamp, and I have set a volt limit of 2.5 volts. So I have the resistance hooked up to the 6500 and the diode hooked up to the 2450. If I have a VTL5C3 at 1 milliamp, I should see 20 k ohm, but I should see an off resistance of about 10 megohm. Obviously, we're seeing almost 100 megohm. So I should see an off, but if I have a type 4, I should see a 400 megohm off resistance. So let's ask it for a milliamp at 1 milliamp. I'm going with the thoughts of I have a type 4 material. Doing that, if I go with 1 milliamp, we should see 1.2K. So we'll output some power. We have a V forward of 1.5 volt at 1 milliamp, and we are seeing 1.4K. So a little high. So that's what I was warned by another technician who had also had problems with these, is they will read high and out of spec. So that's off by about 200 ohms. Let's bump it to 10 milliamps, which should drop it down to 125 ohms. And see if we still read high. So we'll do 10 milliamps. Oh yeah, this part's bad. I'm going to bump it to 40 milliamps, and we should be down to 75 ohms. So it's reading a little high, but close. Now that could be enough to mess with the control loop. So doing a bit of quick math, at 85.5, we're running about 1% high. Or I'm sorry, we're running about 13% high. So that's not good. Okay, so I think that about confirms it. I was able to confirm that we are looking at a type 4 Vactrol. So it is testing about 13% high, which is probably not doing the control loops any good in the AA501. So I think we have a smoking gun at that point, which means I'm going to need to source some parts. Now there's 5 of them in there. And it's a discontinued part, so of course I'm going to have to go looking. Also see if there's anything. If anybody knows of a suitable modern replacement, that would be pretty sweet. I'd like to put new parts in if I can, but I will look around, source for some parts, and when I source some parts, we'll be back at it. Now, the other thing is, I did notice I have a relay board designed for the relays up here. I do not have a relay board designed for the relays down here. So what I'm going to end up doing is I'm going to take some measurements while I have this open and out, and I'm going to add a 3-section relay board along with the 4-section relay board. So if somebody has a relay problem in this section, we'll have something to replace it with. Yeah, all in all, not terrible, but not great. But that is the way it goes sometimes. So since I'm going to have to put this on pause, that's all we have for today. Click the subscribe button, all the bells, and all the links. And I will see everybody in the next video. More is always on the way.